Today we're going to learn the third method of solving systems, which is the elimination method. The elimination method works best when the equations have x and y on one side of the equal sign, and the coefficients of one of the variables are opposite signs, same number. So here's our example that we're going to work through. My equations are 2x minus y equals -2, and -2x plus 3y equals 10. Your first step, you want to make sure that everything is lined up. So your x's are lined up, your y's are lined up, your equal sign is lined up, and your constants are lined up. So step one, you need to make sure that everything is lined up. And then you want to check to make sure that one of your variables has the same number opposite signs. So if we look at this, my x's have 2 and -2. That's the same number, opposite signs, because one's positive and one's negative. The next step, we're going to add our equations together. And the way we do this, it's kind of like when you learned how to add back in grade school, and you would put the two numbers on top of each other and add. We're going to do the exact same thing. We're going to add 2x plus -2x, and that becomes a 0, and they zero out, and they are eliminated. That's why we call this the elimination method. This -y, that's the same as saying -1y. So when I add -1y plus 3y, I get 2y equals, and now I need to add -2 plus 10, and when I do that, I get 8. So now I have a very simple equation that I can solve. 2y equals 8. So step 2 was to add the equations. Step 3, now I'm going to solve this equation. And it's a very easy one to solve. I just have to divide both sides by 2, and that will get rid of that 2 that's multiplying the y, and now I have y equals 4. Now remember, if your problem has x and y in it, your answer has to have x and y in it. So your next step, step 4, is to plug your answer, which I got here is 4, into either original equation and then solve for your other variable. So solve for x in this case. So I can plug it into either this top equation or this bottom equation. Either way will get me the same answer because the solution to a system is the x and the y that make both equations true. So I am going to plug it into the top equation. So when I do that, I would have 2x minus, now instead of saying -y, I'm going to say -4 because I know y is 4, and that equals -2. And now I can solve this equation to figure out what x is. So I start by adding 4. That'll zero out with this -4, and if I add it to the left, I have to add it to the right. Now I have 2x equals 2. And to solve this one, I'm going to divide both sides by 2. And then I will have x equals 1. So now I know what x is and I know what y is, so my final answer is 1, because remember your x coordinate comes first, and then 4, your y coordinate comes second. And there is my final answer. Now we're going to talk about what you would do if instead of the equations having opposite signs, what would you do if they have the same number but they're both positive or they're both negative? So when we added a positive and a negative together, we got a 0 and it eliminated, and that's what our goal is. So now if I add a positive and a positive together, it won't give me 0. So instead of adding, what I can do is I can subtract. So since the coefficients are not opposite signs, my 2x and 2x are both positive, instead of adding the two equations together, I can subtract them. The biggest thing you need to make sure you're watching out, though, is that you have to subtract every term. You have to subtract everything. So I'm going to do the same kind of thing. I like to put parentheses around my bottom equation, and that just kind of is a clue to me that I need to subtract every single term in that equation. So now I'm going to subtract 2x minus 2x. Those will zero out and eliminate. 7y minus 3y will become 4y. And then 13 minus 5 is 8. So now I have eliminated my x. I only have y left. I have a simple equation that I can solve. So step 2, solve the equation. So when I'm solving this equation, I'm going to divide by 4 to get rid of that 4 that's multiplying the y. And then I would end up with y equals 2. Again, if your problem has x and y in it, your answer needs to have x and y in it. So my third step is I'm going to plug my answer into either original equation and solve. So I'm going to plug it into the top one. It doesn't matter which one I plug it into because it needs to work for both of them. So I would have 2x plus 7 times 2 instead of 7 times y equals 13. I multiply 7 times 2 and I get 14 equals 13. And now I can subtract 14 to zero out that positive 14. And when I do that, I end up with 2x equals negative 1. And then my final step will be to divide by 2. And I get x equals negative 1/2. So my final answer is the ordered pair. X comes first, so negative 1/2, and y is 2. And that is how you solve a system using the elimination method.